All right. Like I said, we're going to go over this kind of as a group. I'm going to do the first one so that you can see it, and then I'm going to let you do the other 7, and then we'll go back over and check it. We're not going to spend a ton of time on this. This is just mainly for practice. I had all this information on the board all yesterday and all last week, and then I erased it. So you should have what each one of these little symbols represents. You should know what the A is going to represent, and what the little horseshoe symbol is going to represent, what the V is going to represent. And then also the prefixes, the uppercase M, that represents a certain number. The lowercase m represents a certain group of numbers, and then the letter K also represents another group of numbers. So, this first one right here, first part of doing anything with this is understanding what this right here means. So the A is amps, and then if we put that little m in front of it, that is milliamps. So milliamps means that it is less than 1. It's a very small amount. And any time that we use this lowercase m, what we're doing is we're moving the decimal place 3 spaces to the left of the first digit. So on a meter screen, if we had the meter set on milliamps, it would read 128. Now, if we set it to the amps, so on this particular meter right here, we've got DCA, which is DC amps. So we've got a 200 milli scale right here. So this would be the scale that we see right here. Now, if we bump this up to the next one, it's going to be everything from 0 and higher. So what we have to do at that point is we have to move the decimal place back over. So right now, we have the decimal place 3 places to the right, indicating everything is a whole. If we move it up a scale, that means that it's going to move the decimal place 3 places back to the left. Okay, so milli is everything less than 1. So that would be all of these numbers. So for this scale, if you're on the milli scale, the meter is automatically going to move that decimal place 3 places to the right for you. But if you move the scale, click it up 1, then you put it on a unit that is much larger, that means that you have to be able to move it back those 3 places. So on an amps setting, 128 milliamps is equal to this. But also keep in mind that on a meter screen, we turn this on, you can see it's only got 3 digits. Okay, so if we had this number, we probably wouldn't see the 8. So it would be less accurate. You might think that it's only 12 when it's really 128. So having this thing set up appropriately is very, very important for you to be able to get accurate readings. So I want you to spend about 5 minutes and work your way down through the rest of that page, and then I'm going to put the correct answers on the board, and hopefully what I put on the board matches what you have on your paper. If it doesn't, then you need to kind of look at it and figure out where you made a mistake. Spend just a few minutes doing that, and then we'll go over them as a group. And if you have any questions, please ask. all you had to see whoever's in charge at your high school in charge of tech. If you're having password issues, you're going to have to see your tech person, whatever school you attend. That means you need to move the decimal place over 3 digits this direction. So if you take the decimal from 1, 2, 3, you're going to add a 0 after that digit. So that would be 3,480 ohms. A few more minutes. If you have questions, please ask. I'd be glad to help you. All right, if you're still working, that's fine. Like I said, this is just for practice. You are going to keep this paper, but keep in mind that you will see this again. You're going to see the same exact thing again. The only difference is the numbers are going to be different. So you're going to take a quiz later on, sometime in the next week or so, and you're going to see this same exact information. So if you keep track of this, it should make it very easy for you. The next one, identify ohms. So that symbol that represents ohms, and we have the K, which represents kilo. So we're talking about thousands. We're no longer talking about single or double digits. We're talking about a very big number. So the meter screen, again, only has typically 3 digits. We're going to have at least 4 when we're talking about thousands. So this 3.48, what we're going to do is, kilo represents 1,000. So we're going to take the decimal and we're going to move it 3 places to the right, and then we're going to have to add a 0. So if we move this dot right here 3 places, and then we add a 0, that number becomes 3,480 ohms. So very big number. Okay, number 3. The letter V, we're talking about volts. And we have the lowercase m. So again, that's milli. So this is going to be the same scenario as the very first one. So we've got this number 450. We're going to move the decimal place back to the left 3 places. So that means that this becomes 0.450 volts. That's almost half of 1 volt, but not quite. Number 4, 50,000. So that's a very, very large number. So we are going to move the decimal place back 3 spots. This is simply going to become 50K. So 50 kiloohms. Number 5, millivolts. So we're going from a decimal to millivolts. So we're going to move it 3 places to the right. And that's going to become 27. Now, number 6 should be very easy. Millivolts is always less than 1. So if you have over 4 digits, that means you've exceeded the number 1. So we're going to take our decimal and move it back to the left 3 places, and this is going to become 1.209 volts. Number 7, going from amps to milliamps. So 0.212 amps is equal to 212 milliamps. Move the decimal place 3 places. And then at the very bottom, we've got 80 millivolts, and we're going to volts. We're going to move the decimal 3 places again in the opposite direction. So hopefully you get the understanding of this. If you don't, please make sure that you ask me questions. Now I'm going to pass out these other papers. This one is for you to keep. You are going to turn in the one that I'm getting ready to hand you. And when you get this one correct, then I'm going to hand you one of these meters and one of the little square cardboard pieces, and you're going to start taking some resistance measurements. If you hand me this and it's wrong, I'm going to hand it right back to you until you get it correct. So the first thing that you need to do is you need to, before you even look at the number, look at where the dial is pointing and identify, are you measuring amps, are you measuring ohms, or are you measuring volts? So when you put your answer down here, you have to identify it just like this. So if you just write the number, even if the number that you write is correct, if you don't identify and tell me what it is that you're measuring, I'm going to tell you it's wrong. So this is 128 milliamps. It's not just 128, or millivolts, or volts, or ohms. Whatever it is, you have to identify it. And these are different. So you get a different one than the first sitting close to you. So first, look at the dial. Figure out, what are we measuring? Are we measuring ohms? Are we measuring volts? Or are we measuring amps? And then look at the scale that it is on. And then look at your number. And when you think that you have it correct, I'll look at it. And if it is correct, then I'll give you a beat. If it's not correct, then I'll tell you. Okay, so you're on what scale? What are you measuring? Are you measuring volts, amps, or ohms? Right now, you just got the number 100. That's correct. So you're measuring volts, but you have to look at the scale that you're on. So you're sitting on this number. What number is it? Okay, so that means that you can measure anything between 0 and 20 volts. So right now, you have a very tiny number. So how many volts would it be? Also, make sure you put your name on. Okay, this is correct. This number is not. You're going to add some decimals to it. That's exactly what you're going to do. Here you're going to have 3 decimals. Make sure that you get it appropriate amount. Okay, here's your correct. Yes, there you are, where you're going. That's correct. So how many millimeters is that? Make sure you have it. Now, this is just a bunch of wire. This one could be connected here, or it could be connected here, or it could be connected here. You can't see. So, what you're going to do is, first turn here on. And we're going to put this on appropriate scale. So right now it's on DC volts. We're trying to measure resistance. We're going to move down here. You got 1, 2, 3, 4, 5 of these that you can choose from. So what I want you to do is, you got B1, B2, B3, and then W1, W2, W3. And that's how it's shaped to the over. And it goes down. And what I want you to do is, I want you to measure between each one of them. Tell me what, if any, resistance there is. So first, make sure we have a weak connection. So right there, that means we have no connection. We got open circuit. Now we've got perfect connection through the weak. If we touch between here and here, it's telling us that we have 7. You may need to bounce it around, so what you may need to do is you need to look through it. So then, okay, so this is showing 0, 0, 6. Now here, this is a 200 scale. So what that means is we can measure anything between 0 and 200. And if we try to measure it, see if it's going easily. Walk up and see. Yes, we have the same number, but it's not accurate because the decimal place go back down. Alright, so this would be 6.7 or 6.8. It is very, very small. So then we're going to come out here and see if we get any. Walk up and see. We look through all of these just to check to make sure. You're going to see if we get connections on between all of these. You've got some connection there. Down scale. Most of that is showing 18 on the 2000 scale. 18, so we want to write on ohms. Now, if we go up here, that would be killing it. This is not 10 volts. 10 volts, we're going to get 10 over here. 1, 0, 1, 0. This is less than 1 volt. So if it's less than, it's going to be small scale. Okay, so we are on kilo scale, which means measure thousands. That means that you can measure anything between 0 and 20,000. Okay, so if you have, this wouldn't be K, it would be K. So that means that you have 12,870 ohms. You need this simple, yes. If you're less than 1, you're not going to be on volts. If it's less than 1, it's going to be something different. Okay, so you're going to flip the paper over. You can use it as a this. And you can label it D1, D2, D3, D1, D2, D3, whatever you measure in ohms. I'm going to put this on the lower scale. So this one, that means that you have an open circuit. That means there's no connection. If you have a connection, it's going to display none. So with the perfect connection, it's going to be very close to 0. If it goes there long enough, it's going to go up. Now what you're going to do is, you're going to see what, if any, connection you have between this and this. Okay, so if you have, if it's showing out limits, then what you can do is it may be a higher number, so bump your meter scale up. So turn the dial. Right? If we're staying here, so we're going to keep going up. So you got 1, 2, 3, 4, 5, and choose one. This is a little number. Okay, so we started out here. It's showing that because it's higher than the number 200. And then go up 1. Okay, so now we got it. Right now we can measure anything between 0 and 200. if we have inflation here, it has to be higher than the number 200. There we're about 2,000. So now we can measure anything from 0 to 2,000. So we have, let's sit there and kind of simple out. So we have somewhere around 992, 980. And if you go up again, it's going to give you that same number, but the decimal place is going to be different. So now the decimal place is to the left. So that's not very accurate because it might make you think that you have 1.0 or 0.9 ohms. In reality, it's 1,990. So what I want you to do is label back your paper, and then I want you to tell me what the resistance is between each one of these. So you might have a resistance between here and here. You might have a different one between here and here, and then here, 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 here. So you've got like 10 or 12 possibilities as far as resistance goes. So if you have this, make sure you go through every one of these scales. If it stays that means there's no connection there, and that's going to be 0 ohms. Okay, we've got lowercase m, milli, and measuring volts. And you put V on it. Right now, we break it down. Way too far over. You're only going to be moving things 3 spaces, one way or the other. So this is 0.100. It's not showing 0. It's all the way over here. So that would be 0.100 would be. Okay, so that's 100 millivolts. And I want you to tell me what about this. So you never put everything here. You measure milliamps. How many milliamps is it? Okay, so flip your paper over. These are the labels. DVOM, label, and measure resistance. And start out on a small scale. If you have an open circuit, which means there's no connection, this is what the meter is going to say. If you touch the leads together, that'll get very close to 0. If you hold it very long, it'll go all the way down. So what you're going to do is, you're going to measure the resistance between each one of these connections. So you've got a connection here and here, 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 here. So you've got 10 or 12 different possibilities. So what you're going to do is, you're going to touch each side. Okay, so we've got a number. It's a very low number. This is the smallest scale that we can have. So what that means is that this is pretty close to 1.2 ohms. Right now, 1.2 ohms. It's going to bounce down. Now, if it stayed this, then you go up a scale. See if the number changes. If it doesn't change, then you go to another scale. So make sure that you go through all the scales before you decide it does not have a connection. Here, here. We get that. So now we got a number. Go down. we have more than 200,000. Looks like it settles out around 620K. 620, 62. Okay. 620,000. Alright, and then here. We got a massive amount of shit there. If I pull it, let it settle down. You're going to do that between each one of these lots of connections. And you're going to start on the lowest scale each time, and go through each one and see if you can find numbers. So here, if you're on 200 scale, that would just be simple ohms. If you're on the 2000 scale, then it's going to go up to kiloohms. So you get 2 kiloohms, or 1 kilohm, 1.5, 20K would be anything between 0 and 20,000. 200,000. Keep on doing the same thing.